So let's talk about this idea of these definitions of these trigonometric functions. And we have the three main ones that we're going to just concentrate on is y equals the inverse sine of x, y is the inverse cosine of x, and y equals inverse tangent of x. And as we were just discussing, when it comes to the inverse sine of x function, we define it as follows. We say y equals the inverse sine of x if and only if x equals the inverse sine of y, where x is a value from -1 to +1. You'll recall that was the range of the original sine function, and y is limited to values between -pi/2 and +pi/2. So when you're finding angles in the plane for this inverse sine function, when you're solving for y, remember that the y values must be y values for angles that are in the first quadrant with a positive value, or the fourth quadrant with a negative value, and that's it. You're not going to get a third quadrant angle or a second quadrant angle on the basis of this inverse sine function, because we're going to go from -pi/2 to +pi/2. All right, how about the inverse cosine? Well, if we go through all of the steps as we just did before in the last video with sine, then what we find is that our inverse cosine function, y equals the inverse cosine of x if and only if x equals equals cosine of y, x is a value also between -1 and 1. If you recall that the principal domain of the cosine function was range was -1 to 1, and the principal domain is 0 to x. So in our inverse trigonometric function, y goes from 0 to pi. And I should really make that correction right now. Stand by. Y is based from 0 to pi. So what's going to happen is that anytime you take an inverse cosine of a function, the y value that you get will be limited to angles that are in quadrant 1 or quadrant 2 and have values that range from 0 to pi, and that's it. We won't get a fourth quadrant angle. We won't get a third quadrant angle by the use of this inverse cosine function. Okay, one more, and that is our inverse tangent function. And for our inverse tangent function, in a similar way to what we've been talking about, y equals the inverse tangent of x if and only if x is equal to the tangent of y. And x this time is from -infinity to +infinity. If you recall our discussion about that principal domain and range of the f of x equals tangent of x function, we limited x to going from -pi/2 to +pi/2, but the y values are not bounded by an amplitude as they are with sine and cosine. And so our domain will be negative to positive infinity, but our range will be -pi/2 to +pi/2, sort of similar to what we were able to do with this sine. But you'll notice again that the y values here do not include those endpoints. Why? Well, that's right, because those are asymptotes. So in our values right here, for tangent, when we take an inverse tangent, our values for our angles will be from quadrant 1 or quadrant 4 only, with values that range from -pi/2 up to +pi/2, but not including pi/2 or +pi/2. So I'll put a little open circle right here to represent that. And our y values, our angles, will be standard position angles between those values.